All right, here we go, everybody. What's up? This is assignment 10C, which again, we are still in the chapter that is dealing with uh, uh, claim testing, and seeing if a difference truly does exist. And so what we did in the previous couple assignments is dealt with, in essence, hypothesis testing, where you draw a curve and you see where it falls on the curve, reject H naught, accept H1 kind of ideas. Today, what we're going to do is the same kind of idea, but we are shifting to a confidence interval. How to do this on a confidence interval. So again, obviously, we will talk about how to make decisions and how to write things in this video. Let me just put up some of the formulas that we'll need to know to be successful. Okay, question A is first asking for the margin of error. So our margin of error in this case is going to be ZC, and this is going to be sigma 1 squared divided by N1 plus sigma 2 squared divided by N2, and that bit is square rooted. Okay, again, we'll talk about that. And then the confidence interval is going to be given by the formula of parentheses x bar 1 minus x bar 2 minus e, which is less than mu 1 minus mu 2, which is less than x bar 1 minus x bar 2 plus e. Okay. So that is what we are going to be doing, and we will obviously learn how to write this in sentences and things like that. Okay, yeah, let's go ahead and start here. So here it says rapid eye movement. Sleep is sleep during which the most dreams occur. Each night, a person has both REM and non-REM sleep. However, it is thought that children have more REM sleep than adults. Assume that REM sleep is normally distributed for both children and adults. And so we did various studies. So we have children, we had 10 children, and on average, they had 2.8 hours of REM sleep with the standard deviation. And then we also sampled 10 adults, and they each had 2.1 hours per night with a different standard deviation. Okay. So let's go ahead and begin this problem. We have the majority of the variables that we need. We have the sigma 1, we have N1, we have sigma 2, we have N2. The only thing that we don't have is that ZC. I know it's been a little bit since we've done a problem like this, but recall that you get your ZC obviously from the Z table, but it's mostly stemming from the confidence. So because I have a confidence, in this case, of 98%, okay, I look at that Z table at that little box, and that is going to let me know the ZC in this particular problem. So let's go ahead, take a look at the Z table at that little box that is at the bottom of that Z table for a 98% box that I refer to as this. And so 98% is coming with a ZC of 2.33. Okay, 2.33 is the ZC in this situation. This is pretty straightforward. This formula, I know it's kind of long and like a lot of bits to it, but it is pretty straightforward. What I do is I do this inside stuff all in one big formula. So I do x1 squared divided by n1 plus sigma 2 squared divided by n2. Again, fill in the various numbers for those things. Okay, that will get you the inside. From there, you want to square root your answer. All right, and then you need to multiply by the ZC. That's pretty much what you do. So here we go. Sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. Okay, easy peasy. So square root, okay, that's that inside, and then multiply by CC. Easy peasy. Okay, and I know it's been a while since we operated with a standard deviation, or excuse me, a confidence interval. But again, we're in essence taking one number minus e and another number plus e. So the only difference between these two sides is the left-hand side is minus e and the right-hand side is plus e. So it's in essence the same math problem, just one's a minus e and one's a plus e. So here we go, let's set this up. So we go x bar 1 minus x bar 2 minus e and then I do the same thing, x bar 1 minus x bar 2 plus e. So we have this confidence interval. Okay, now, the rest is kind of up in the air. The rest is kind of our interpretation of this. Okay, so this next part is going to be two different parts. All right, just follow my lead and then I'll explain everything. So first and foremost, what I see is that mu1 minus mu2 is greater than 0, thus mu1 is greater than mu2. Okay. Explain that. And then what we do is we, in essence, write that in words. Again, we are talking about mu's, so we do have to use the word average. And where I get this average to describe is whatever this x bar is how I describe my average. Try to avoid using the title of the picture. Look at your x bar. So this would be the average hours per night. Okay, I need to be a little bit more descriptive of REM sleep. And then mu1 is of x1, and that would be of children. So mu1 is greater than mu2. So mu So mu1 is greater than mu2. So the average mu1 is greater than the average 2. Okay. Now, as I said, I kind of skipped over some of the things, like kind of how I made some of my decisions. Let's go back and talk about how some of those decisions were made. Okay, so everything is really, really straightforward as far as the math is concerned. So question A and question B is not really where this problem lies. The problem is all in C. And in essence, what a confidence interval is doing is this. You're coming up with a guess of what this number is. What this number is. And this number is in between two different numbers. Okay, this number is in between two different numbers. Right? So the small number in this case happened to be a positive number. The bigger number happened to also be a positive number. So if a number, okay, this thing is in between two positive numbers, then this thing obviously has to be positive, greater than 0. So if it's in between two positive numbers, it's positive. And so again, looking at my confidence interval, that's what I notice. The low side is positive, and the high side is positive. Okay, I'm not really interested in what those numbers are, but as long as they're, what's the sign of those numbers? So if my middle bit is in between two positive numbers, then it's positive. If it's in between two negative numbers, it's negative. And then if one is negative and the other one is positive, then we don't know. So let me kind of boil this down to what I'm seeing and how to make a decision. Okay, if the low side is positive and the high side is positive, then what you say is mu1 minus mu2 is greater than 0, because it's positive. If it's negative, negative, if the low side is negative and the high side is negative, that means mu1 minus mu2 is less than 0. If the low side is negative and the high side is positive, then that means mu1 minus mu2. And what I do is I write it just a question mark of 0. And so the words that you say, again, you have to use the word average. So the average of 1 is greater than the average of 2. So the average of 1 is greater than the average of 2, or the average of 1 is less than the average of 2. What you say when you have that I don't know answer, okay, what you say when you get that the question mark result is we say we are unable to prove a difference between. And then so mu is the average. So we are unable to prove the difference between the average, again, because we are talking about mu's, the average hours per night of REM sleep of children, so 1 versus 2. So that's what we'd say if you get that question mark result. Other than that, it's pretty much what is written up there in red. And I think we'll get that alternate answer in this question number 2. Okay. Now, a keynote difference that you'll also have to make is this. Number 1, notice how you're dealing with sigmas. Number 2, you're dealing with s's. Okay, so what's going to happen is we are going to be getting a t value in some of our places, and we're going to have to use the t table. Again, we'll obviously talk about all of that, and so here we go. So again, I like to start off with formulas. So here we go. The margin of error, in this case, because we have s's, is going to be TC S1 squared divided by N1 plus S2 squared divided by N2. Very almost the same thing, just with a TC. All right. How to get that TC? Again, I know it's been a bit since we've done this. So what we need is the DF/C in this case. All right, so the confidence, very easy, is going to be 98%. So we're looking for 980. Okay, that's the confidence that we're looking for. But what is the degree of freedom? And the problem is, yes, we all know that it's n minus 1, but the problem is, what the heck is our n? Here we have an n of 10, and we also have an n of 12. So what the heck is our n to use the degree of freedom? And it's actually more simple than what you would think. What you do is you use the smaller of the two n's. You use the smaller of the two n's. So the smaller of the two n's right now is 10, thus the degree of freedom is going to be 9. So you take the degree of freedom from the smaller of the two n's. So we have a degree of freedom of 9 and a confidence of 98%. Okay, and so now we go ahead and use the t-table to find this TC, and then we'll be set up for this equation. So the t-table, 9 at 98%. So degree of freedom of 9 and a confidence of 98%. Gives us a TC of 2.821. And again, the reason I find this TC is because this problem has an S, not a sigma. Okay, so we go ahead and do this very similar to how we did the first one. So we take S1 squared divided by N1 plus S2 squared divided by N2. Okay, so that's the inside. I square root that and multiply, in this case, by TC, which is 2.821. Confidence interval is exactly the same thing, so x bar 1 minus x bar 2 minus e is less than mu 1 minus mu 2 is less than x bar 1 minus x bar 2 plus e. So here we go, x bar 1 minus x bar 2 minus e and x bar 1 minus x bar 2 plus e. So what I'm really looking at with these problems is I see that this left-hand side is negative and this right-hand side is positive. The left-hand side is negative and the right-hand side is positive. So that means I don't know if this middle part is negative or positive. I can't definitively say. So mu1 minus mu2 is I don't know compared to 0. And so how do these two things compare? I don't know. I'm not sure. So what do I say when that middle part is a question mark? We are unable to prove a difference between the average of 1 versus 2. Okay, so again, I look at X bar for my description, so violent crime rate. New England versus Rocky Mountain States. So we are unable to prove a difference between, again, this has to have the word the average, okay, because they are mu's. Those are averages. So again, if they're both positive, then it's greater than 0. If it's both negative, then it's less than 0. If one's negative and one's positive, then it's question mark to 0. Okay, same problems, well, similar problems, just do it again. Okay, this problem is dealing with the sigmas. So this is going to be the ZC, so E is ZC, sigma 1 squared N1, sigma 2 squared N2, square root. Okay, this again has a confidence of 98%. So that means, the ZC, we have to look at that Z table. At that little box, 98% says that is 2.33. Okay, so we can go ahead and pretty much do this. So sigma 1 squared divided by N1 plus sigma 2 squared divided by N2 square rooted times ZC. We go to our confidence interval. The confidence interval is, again, x bar 1 minus x bar 2 minus E. It's less than mu1 minus mu2. It's less than x bar 1 minus x bar 2 plus E. There we go. X bar 1 minus x bar 2 minus E. X bar 1 minus x bar 2 plus E. I see that one's a negative and the other one is a positive, so that means mu1 minus mu2 is question mark to 0. That means mu1 is question mark to mu2. We are unable to prove a difference between those two things. So that is going to be the pollution index, the average pollution index, excuse me. Denver versus Inglewood. If you do real studies, like if you were to actually do a lot of statistics and things like that, you're going to, the majority of the problems that you do will end up with like question mark in the middle. We're unable to prove the thing. rarely are you able to actually prove anything in real mathematics. Like it's very rare that you actually can. Um, so in real life situations, these are going to be the majority of your answers. All right, number 4 is the same type of problem, but this has an S, so that means we're going to be getting a TC to help our margin of error. So our margin of error, again, is not ZC, but rather TC because it has S1 squared and S2 squared. All right, so because I have a confidence of what, 90%, and a degree of freedom, again, use the smaller of the two ends. The smaller of the two ends is 14, so my degree of freedom is 13. Smaller of the two ends is 14, so that means I'm looking at 13. So degree of freedom of 13 at 90%. Degree of freedom of 13 at 90%. $1.771. So I have enough stuff to get this done. So 1541 S1 squared divided by N1 plus S2 squared divided by N2. Square root that and multiply by TC. Okay, the confidence interval in this situation, again, x bar 1 minus x bar 2 minus e is less than mu1 minus mu2 is less than x bar 1 minus x bar 2 plus e. All right, so here we go. X bar 1 minus x bar 2 minus e have a positive number here. And x bar 1 minus x bar 2 plus e. Okay, so what I notice about that confidence interval is that both numbers are positive. Both numbers are positive. So that implies that mu1 minus mu2 is greater than 0. It's a positive number, which means mu1 is greater than mu2. So the average of 1 is greater than the average of 2. In these cases of hay fever. So the average of 1 is greater than the average of 2. People under 25. So the average of 1 is greater than the average of 2. That's it.